In section 6.2, we are going to look at properties of parallelograms. So remember, in a parallelogram, you have two pairs of opposite sides parallel. Well, theorem 6.1 tells us that you also have opposite sides congruent. So in number 1, we want to find the value of x and the length of each side. So opposite sides are congruent tells me I can write an equation that says 4x minus 3 equals 2x plus 9 to solve for x. So subtracting 2x, I have 2x minus 3 equals 9. Add 3, we get 2x equals 12. And then finally divide by 2, we get x equals 6. So if x is 6, then let me find the lengths of each side. Since they're congruent, it does not matter which expression we substitute in for. So, using the one on the left, 4 times 6 minus 3, or 24 minus 3, which is 21. So the lengths of both of my sides are 21. In a parallelogram, consecutive angles are supplementary. So in number 2, we want to find the other three angles. So if I take 180 minus 60, I get 120 degrees. So that means this angle is 120 degrees because it is consecutive with the 60. And then also this top left angle will be 120 degrees because it's consecutive with the 60. And then if I took 180 minus 120, I would just get 60 again. So then the top right angle is 60 degrees. Now in the last example, we even solved this theorem, that opposite angles of a parallelogram are congruent. So in number 3, it says find the value of x and the measure of each angle. If our opposite angles are congruent, can say 135 minus x equals x plus 15, and then we can solve for x. So I'm going to add x to the right and have 135 equals 2x plus 15. Subtract 15, I have 120 equals 2x, and finally divide by 2 to get that x equals 60. So if x is 60, let's find the measure of our angles. Does not matter which one we substitute in for. I'm going to choose the top right just because we are adding instead of subtracting. So take 60 plus 15 and we get 75. So that tells me this angle is 75 degrees and this angle is 75 degrees. Then if I wanted to find my other two angles, I could take 180 minus 75 and get 105. So it tells me this angle is 105 degrees and this angle is 105 degrees. Our next theorem tells us the diagonals of a parallelogram bisect each other. And remember, the word bisect means to cut in half. So the diagonals are cutting each other in half and making two pairs of congruent segments. Number 4 says find the values of x and y in quadrilateral ABCD. Then find AE, EC, BE, and ED. So let's go ahead and label our quadrilateral. So I'm going to mark A, B, C, and D, and our midpoint as E. So if the diagonals bisect each other, I can write two equations where we set the expressions equal to each other. So I can say 2x plus 5 equals 5y, and x equals 7y minus 16. And I wrote it this way so that my x's are both on the left and my y's are on the right. So here we have a system of equations. And this is a review from Algebra 1 on how we solve these types of problems. I'm going to use substitution. So I'm going to take what x is for my second equation and substitute it in for x in my first equation. Alright, so instead of writing 2x plus 5, I will take 2 times 7y minus 16, then plus 5 equals 5y. Now I have an equation that just contains y, and we can go ahead and solve this. So first distributing, we have 14y minus 32 plus 5 equals 5y. Combine like terms, so 14y minus 27 equals 5y. Then subtract 14y, so negative 27 equals negative 9y. And finally divide by negative 9, we get that y is 3. Alright, so if y is 3, we have to solve for x. I'm going to use the second equation, which tells me that x equals 7 times y, and we just found that to be 3, minus 16. So 21 minus 16, or 5. So y is 3, x is 5. Let's find the lengths of our diagonals. Alright, so AE, and that's actually the expression I just used to solve for x. AE says take 7 times y minus 16, and we get that AE is 5. Well, if AE is 5, the other diagonal EC will be congruent, so it's 5. Let's solve for BE. BE will take 2 times x, which is 5, plus 5. So 10 plus 5, or 15. And finally, ED is congruent to BE, so it is also 15. Let's look at our last theorem and example for this section. Theorem 6.4 says if 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. So number 5, we're told that line DH is parallel to line CG, which is parallel to line BF, which is parallel to line AE. We want to find FG, GH, and EH. Okay, well, we're told on the left side that AB is 2, BC is 2, and CD is 2. Our diagram is marked that EF is 2.5. So the theorem just said we have, so in this case we have 4 parallel lines all being cut by one transversal. So it's going to make all of my segments congruent. So that means this will be 2.5 and this will be 2.5. Alright, so FG is 2.5. GH is 2.5. And to find EH, we're just going to add those 3 up, or I have 3 segments that are each 2.5. So that makes the total 7.5. Alright, and this concludes section 6.2, Properties of Parallelograms.